Hello, my name is CORPIN. I'm currently a fourth year chemical and biological engineering student and an intern for both CSU and community energy to research carbon capture and sequestration techniques. Today I want to talk about ways large-scale manufacturing companies can minimize carbon dioxide emissions using two different techniques. I first want to put things into scale. Producing just one electric vehicle lithium battery emits 12 to 80 tons of CO2. Times that by the thousands produced each year, and it adds up quickly. In fact, the industrial and energy sectors produce around 60% of global CO2 emissions, shown in the figure below. We can capture the CO2 before it hits the air, but what to do with it after it is captured is still contested. This leads me to the two sides I will present today on what to do with captured CO2. Side A suggests burying it completely underground, called CCS, and Side B, suggests turning it into something we can actually use. Then I will share which path makes sense going forward. Let's start off with Side A, geological storage, or CCS, meaning carbon capture and storage. One of the primary techniques currently used and is known to work is injecting CO2 underground into saline qualifiers, deep oil gas reservoirs, or basalt rock. This is called geological storage and is already being used commercially today with companies like Black & Veatch and ExxonMobil. Its strengths are it has a relatively simple mechanisms, making it cost low, and it's able to capture a lot of CO2 for hundreds of years, so not completely permanent. Some of its weaknesses are that it is site limited and is not suitable for storage in all land types. There's a high risk of leakage, so contamination of water sources like drinking sources, and increased risk of earthquakes and injection site due to that increased volume when injected. It's also not profitable for all companies. Companies have to be very intentional about doing this, knowing that they won't make profit and are just doing it because it's helping the environment, which some companies don't like to do. This leads us to Side B, which is another and newer approach where we can take captured CO2 and react it with waste minerals such as steel slag or fly ash, which are full of calcium and magnesium ions, to create a solid rock-like material. This is completely permanent for up to thousands of years compared to hundreds, unless it's exposed to extremely high pressures and temperatures, which are unlikely. Its products can also be sold, used in the concrete and construction, which is shown in this figure on the slide, and this can help offset the high cost by making it profitable for companies and more marketable for them. It also utilizes waste and energy already present and uses them into something useful. Some of its weaknesses is that it captures less CO2 overall compared to geological storage, and it's a relatively new technique, so it's still in its early stages and has less large-scale validation and companies using it. There's also high costs associated with additives and catalysts associated with the process, and then contamination risks with using waste products. In conclusion, both sides are effective ways to capture CO2, and there's not simply a right or wrong way. CCS is simple and proven, but carries environmental risk and no return, while CCSU turns carbon into a revenue, but is newer and costlier upfront. My position is that CCSU is the stronger long-term path for companies with waste minerals already present on site, and it has a high profitability, while CCS still matters for facilities where access and scale matters most. My recommendation is that we continue researching feedstocks and looking specifically what feedstocks are available in industries already present, and we continue piloting CCSUs where waste minerals are available. We still want to continue using CCSs elsewhere, just making sure to keep them away from seismic and water risks, and continue researching both of them. Bottom line, the goal is not picking a winner. It's giving manufacturers an informed way to make realistic ways to cut emissions. Here are my references. Thank you for listening to my presentation. Here's my contact information for any further questions.